Okay, today we're doing 5.3 day 2, and we're going to evaluate integrals using antiderivatives. This is a little bit more accurate sometimes than figuring out actually it shouldn't be more accurate, it should be the same, but sometimes you cannot figure out antiderivatives based on geometric shapes. You have to use the antiderivative. On your purple sheet, I have listed next to derivatives all of the antiderivatives. You need to know all of those antiderivatives along with all of those derivatives. They're opposites of each other, they're inverses of each other. So, and that's actually the fundamental theorem of calculus, but we'll get to that later. But they are opposites or inverses of each other. So it shouldn't be too hard to memorize the antiderivatives. Okay, so when we take the antiderivative, you have a lower limit and an upper limit of integration. So the integration is the same as the antiderivative. And when you have specific numbers in here for a and x, or a and b, sometimes we've called it, then you actually can calculate those by taking the function that's the antiderivative, plugging in an x, and subtracting the function that is the antiderivative and plugging in the lower limit, or the a number. All right, that is called a definite integral. That means we get a specific numeric answer. Numeric answer. Now, what is true of indefinite integrals is that you don't get a numeric answer. What you get is a function with an x in it, a function with respect to x, which is the antiderivative. So we'll do some of both. And what you have to do with indefinite integrals is add a c, and you'll lose points if you forget to add c. So remember to add c. All right, this is a definite integral, and it's the integral from 0 to 2 of 5x dx. All right, so what we need to do is take the antiderivative at 2 and subtract the antiderivative at 0 to get our solution. All right, the way we get the antiderivative of 5x is that, remember, it's x to the 1. We add a 1 to this, and we divide by our new exponent. So our antiderivative is going to be 5x squared over 2. So this is our antiderivative. So now what we're going to do is take this 5x squared over 2 and you plug in a 2 and a 0. So we have 2 squared over 2 minus 5 times 0 squared over 2. And the answer we get is 10. That is our answer. Now, this is the same thing, except we have to take a different antiderivative. We're going from negative 1/2 to positive 1/2. All right, so let's write it out so we don't forget something. This is the function at positive 1/2 minus the antiderivative function that is at negative 1/2. All right, so this function, if we look at our antiderivative chart or at our brain, we find that this is the inverse sine function at 1/2 minus the inverse sine function at negative 1/2. So you can put this in your calculator or know from your 30, 60, 90 degree triangle that sine of 1/2, or sine, the angle where sine is equal to 1/2 is pi over 6, and where sine is, negative 1/2, that should be a negative there. I can't write it in because of my board. But anyway, negative 1/2 is at negative pi over 6. And therefore, your answer is pi over 3. which is the same as 2 pi's over 6, because this becomes a plus. All right, that is your answer to this problem. And we have the mean value theorem for integrals, which we've already talked about. And so this is a little review slide. But now we're going to use the average value of the function, and this is page 291, number 36. And we want to know the point where this function assumes its average value. So let me get our formula from the other page. All right, so we have our formula. We're going to find the average value first. The average value is the right-hand side of this equation. So it's pi over 3 minus 0, because this is A, this is B. And then we take the integral from A to B of secant tangent. Okay, so the interval of secant tangent. And let's do some calculations with that. First of all, we know that our antiderivative function is going to be secant of x. So if we take 1 over pi over 3, we know that we have 3 over pi. And we're going to multiply that times f, the antiderivative, at a over b. We should have pi over 3 minus the antiderivative at 0. We should actually have these changed. It should be 0 to pi over 3 right here. Okay, and so we're going to have to plug pi over 3 into secant and 0 into secant. Or you could make that 1 over cosine. You would find that 1 over pi over cosine of pi over 3 is 2, and 1 over secant at 0 is equal to 1. So our answer becomes 3 over pi. So 3 over pi is your average value, and that is the end of our lesson, which is section 5.3, day 2. Thank you for tuning in.